This is section 726. We're going to take a look at oblique or slant asymptotes. So we're going to graph a rational function that has an oblique or slant asymptote. So remember, we get it when the degree on top is larger. And so in this case, the degree on top is larger, and so we're going to have an oblique or slant asymptote. So the first thing we need to do is we need to factor. Now the bottom, that's easy. That's x plus 2 and x plus 1. The top, because it does say cube, I have to do my p's over q's. And I know you're thinking, you're like, oh, that's still a thing? Yep, that's still a thing. So factors of 1 over the factors of 2. Now, if you ever get something where you have to do your p's over q's, just know it's not as bad. Let's try negative 1. So I have 2, 5, 4, and 1. Add straight down, multiply, add straight down, multiply, add straight down, multiply. See? Super easy. Works. Not too bad. So this is 2x squared plus 3x plus 1. A times c, 2 factors of 2 that add to 3, 1, and 2. Maybe this factors further. So that will factor into that. So on the top, we get 2x plus 1 times x plus 1. And then this is another x plus 1. Now one of those cancel out, so I know I have a whole where x equals negative 1, right? You set it equal to 0, subtract 1 on both sides. Which means I have a vertical asymptote at x equals negative 2. Now I need to find the slant asymptote. And so you do that by dividing. So x squared into 2x cubed is going to give me 2x. Distribute. And then subtract. And then divide. Distribute. Okay. Now, anything else is a remainder. We don't need to worry about it. This is what we need. So our slant asymptote is going to be y equals 2x minus 1. So let's put all of those on the graph. So it starts at negative 1, has a slope of 2, so up 2 over 1, up 2 over 1, up 2 over 1, and then down, down, down. So we have that. And then we have our vertical asymptote at negative 2. So we have that. And so now we need to kind of figure out, what is our graph doing, right? Is my graph over here? Is my graph here? Is my graph here? Is my graph here? And the only way to figure that out is by creating an XY table. And my recommendation is, if for the XY table, when you plug it into the reduced one, which is this. So plug it in for x into that. So for example, if I were to, let's say, plug in, let's try, like negative 1. 2 times negative 1 plus 1, and then negative 1 plus 1, because that's 0. 0 times anything is 0. 0 over anything is 0. So when x is negative 1, that's 0. Now, that's my whole. So at negative 1, 0, I'm going to, put in an open circle there. If I were to plug in 0, I get, is that 1/2? If I were to plug in 1, I get 2. If I put in 2, I get 3 point, I think it's 3.75. So let's just kind of plot those. So we have our -1. We have our 0 is 1/2. We have our 1 is 2. And our 2 is 3.75. Okay, so it's right there. Now it's like, oh, what's my graph doing here? Maybe you need to plug in -1.5. But basically the graph effectively are hugging the asymptotes. So it's going to come down, it's going to touch that hole, probably come down a little bit, and then it's going to hug the asymptote here. I know mine's a little pointy, I can't draw it a little more smoother. This computer's not as good. So I still don't know what's happening at -3 and -4. So we got to plug in -3, -4, -5. Let's see what's going on. Okay, so when you plug in -3, you get -10. Okay, so that's all the way down here. So that's -10. If I plugged in -4, that's -10.5. So it's a little bit more down there. And then if I plug in -5, okay, it's -12. So that's there. So it looks like it's doing something like that. It's not fully fitting on the graph, but it's still following the asymptotes. And that's essentially your graph. So we still find the essential information, and we're just plugging in points to figure it out. So for this one doesn't have any vertical asymptotes. It also doesn't have any holes. This doesn't factor. So no holes, no vertical asymptotes, but I do have a slant asymptote. Now, the reason why is if I set that equal to 0 and square root, I get imaginary numbers. Okay, so that's why there's no holes or vertical asymptotes. So to find the slant asymptote, I need to divide. So x squared into that is x squared. Distribute, subtract, bring down everything else, but it's 0, so don't have to worry about it. So that's minus x squared. Bring down everything else. X squared into negative x squared is -1. Distribute, subtract. Now anything else is a remainder, so we just get this. So that means that this is an oblique asymptote. That means it's a parabola. And this is going to look kind of fun, but essentially my graph moves around this parabola. Now, if you're asking yourself, well, how do I figure out how it moves around the parabola? Well, it's very simple. All you need to do is plug in points. It's been the major theme of everything that we've been doing is plugging in points and seeing what's going on. So if we were to start picking some values around 0, because there's no vertical asymptotes, so it's like I'm not getting any undefined values. So if we were to go through, I don't know, let's just pick -2, -1, 0, 1, and 2. And if you plugged in -2, that's -2 to the 4th plus 1 over -2 squared plus 1. And then I get 3.4. If if I plugged in -1. If you do that, you're going to get 1. If you plugged in 0, you get 1 over 1, so that's 1. If I plugged in 1, that's going to be the same thing as 1. If I get 2, that should also be 3.4 because, everything in there is negative. So if I were to plot this, so this is going to be a little weird. So 3.4, okay, looks I can kind of already tell it's hugging the asymptotes. So I know this is doing this. I know that this is doing this. It's hugging the asymptotes. You don't really find a whole lot of things that are flat in functions. So it's like when I look at that -1, the 0, and the 1, and how they're all 1, it's flat. There's something else going on there. And so my advice is to then, or like, okay, we need to figure out what's going on. So I'm going to do -0.5 and +0.5. You just have to do it. And so when I do that, I get 0.85. And it should be mirrored to the other side, which it is. So it kind of does a little dip. So it'll actually do like that. There's like a dip. Now I suggest we put this into Desmos so you can kind of take a look at it, but it does a little dip there. I don't know how far deep that dip is, but it's good enough. We're just sketching it. But it's kind of weird. It's kind of fun. So what did we learn today? We learned how to sketch rational functions with oblique asymptotes. Just remember that if it's an oblique asymptote or slant, that means the degree on the top is larger. You have to divide the polynomials. You still have to find all the other information, holes, vertical asymptotes, and then from there, you just plug the values in. Create an XY table. This does conclude our lesson. If you have any other questions, please leave them in the comments.